an adiabatic
From
pressure
B
volume?
to C, is that what you said?
B to C,
Yes,
yeah.
yes, we would use an adiabatic relationship.
So is that a different formula for C? Because then we're calculating C two different ways, adiabatically and isochorically.
Yeah, we're not calculating C, we're just measuring C. We're not saying that let's start with temperature B and figure out how C relates to B. I'm saying we start at temperature C and find out how B relates to C. So, yes, if we started at B and we wondered how C relates to B, then we have to do an adiabatic. That's not what we're doing. We're starting at C and seeing how B relates to C. Okay, good. Good question. Where am I? I'm lost. Here I am. So now we've got a statement right here. It's lost. Here it is. We've got this statement right here, which we can finish now. So Q, the heat flow in from C to D is M, oops, M, not N, M, C sub B, delta T, which is going to be PD minus PC over VC divided by NK. So we have an expression now, and all it relates to, responding to your question a second time, all it relates to is the heat flow as it moves simply from this point to that point. And I don't care, at this moment, I don't care how I got here. I only care how I get from here to there. So that's the heat flow in. Great. I then argue that heat out, Q out, heat out, is over here. This is where the heat is out, from E to B. There's no heat flow here, there's no heat flow here. All there is work back and forth here, both of them equal. So the other place that heat flows is E to B. So Q, E to B, is simply going to be M, C sub B, then PB minus PE times VB over NK. Because these two volumes are the same, so I've just elected to call it VB. And the logic would all be the same. It's an isochoric process. The efficiency is going to be work divided by heat in, which is then, of course, the sum of heat in plus heat out over heat in, 1 plus Q out over Q in. Wait a minute, we have to be a little bit careful. There's got to be a negative sign here somewhere. Does anybody spot, from a logical physics standpoint, can anybody spot where there must be a negative sign? There must be a Q out must have a negative sign, huh? To begin with, if it doesn't, we're going to have something more than 100% efficient. Whoa, that's pretty cool. That doesn't happen. That can't happen. So there must be a negative sign there. Let's look back. Oh yes. Look. PE is larger than PB. The pressure at E is larger than the pressure at B. So right here, there is a negative sign right there. If I add in this term, it's going to come in with a negative sign associated. So for Q out, heat out, there will be a negative sign that goes with this number because of that calculation. So we've taken care of that negative sign. That negative sign belongs when we put the number in there. So everything is copacetic right now. Let's write it all down. So the efficiency is what? 1 plus Q out, which we have right here, MC sub B, times PD minus PC, PE minus PC, times VC, divided by Q in, and Q in I just wrote it upside down, didn't I? This is Q.
Yeah.
I was just seeing if you were paying attention. Right? Right. I just wrote it upside down, my friends. So upstairs goes Q out, and Q out is the lower one here. So it is M C sub V times PB minus PE, PB minus PE, times VB divided by NK. Okay, I got it correct this time. Now we divide that by P in, which was the one I wrote a moment ago, M C sub V times PD minus PC, PD minus PC, times V what? VC divided by NK. And there's lots of stuff in common. Let me use these two colors. Of course, I see that there's an MCV above and below. That's gone. There is a divide by NK on both the top and the bottom, so that's gone. And finally, we have a much simplified expression for efficiency. The efficiency of the system is going to be 1 plus PB minus PE, PB, PE, VB, VB. That's all divided by what? PD minus PC, PD minus PC, all times VC. Okay, that's a much simplified version of this thing, but we can go a bit further. We can simplify things a bit further by noticing the connection between these two. Now we're going to get around to the adiabatic processes you were thinking about a little while ago. The connection between these two is two adiabats. So to connect from B to C or from E to D, they are adiabatic processes. Therefore, it's logical in physics to write down the adiabatic processes. Now is the time to do that. So we have P, B, V, B to the gamma power equals P, where am I? B to C, P, C, V, C to the gamma power. Likewise, when I go the other way, it's D to E, so we have P, D, V, D, gamma, and P, E, V, E, gamma. Lovely, lovely. We're actually making progress. Notice that if I subtract the lower equation from the upper equation, I could write P, B, V, B, gamma, minus P, E, V, E to the gamma power, B to E. Aha, those are the same volumes. So I could write P, B minus P, E times V, now let me look here, times V, B to the gamma power. Then, that's these two. Now these two are P, C, V, C, gamma, minus P, D, V, D, gamma power. But again, C and D are at the same volume, so I can factor it out as a PC minus PD times V, which one do I want to use? I want to use VC, VC to the gamma power, so I'll just identify both of these as VC. That's really nifty. Yes, it is nifty, because, of course, I can set those equal to each other. I have PB minus PE, VE VB, the gamma power, equals PC minus PD, B, where am I? VC, the gamma power. And then notice that if I was to write, now watch this, a little tiny trick in here, watch this. PB minus PE divided by PD minus PC is going to equal minus VC to the gamma power over VB to the gamma power. And let me see if that works. It does, because notice one, oh no, maybe you've noticed already. I'm not going to tell you. Why does it work? Or, let me say, where in the world did this negative sign come from? You spotted it. Yes, you did. Aha. See, D, negative D. Negative C, C. I reversed those two with a negative sign. And then I had to put the negative sign back in. So that's where that negative sign came from. Very good. You spotted that. Excellent. All right. Oh, now look, we have an expression here that can go right here. You see? It's the same thing. PD minus PE, D minus C. I can substitute this in place of it. So now we have that the efficiency is equal to 1 minus, where am I? I am right here. 1 minus VC to the gamma power over VB to the gamma power times VB over VC. So, of course, that is 1 minus